Hi dear students, welcome to this online class. Today we discuss some important numericals which comes in solid state, which is based on mainly an equation, that is the equation for density of crystal. So you know that density is mass per volume, and you know that in the case of crystals, all the properties of the crystal is present in its unit cell because it is the basic fundamental unit of the crystal. So to get the density of a crystal, we can calculate the density of the unit cell, which will be the same. So how you get density of a unit cell, which is cubic, because we mostly deal with cubic crystals. It will be mass of the unit cell divided by volume of the unit cell. If it is a cube having an edge length of A, side of the cube is A, suppose, right? This is A. Volume of cube is A cube. So volume of the unit cell is A cube. Now what is mass of the unit cell? It depends upon the type of lattice. Suppose it is a simple cubic, there will be particles only at the 8 corners, and you know that the effective number of particles per unit cell for simple cubic is 1, because it is 1 by 8 into 8, you know that. If it is BCC, it will be 2, because there will be one more particle in the middle of the cube. That means it depends on Z. So number of particles, or we assume the constraint particles to be spherical, so number of spheres, that is Z. And what is the into mass of one particle? How you get mass of one particle? Suppose it is copper crystal, for example. What is the mass of one copper atom? That is obtained from the mole concept, you know. 1 mole of copper will contain Avogadro number of atoms. So mass of one atom is molar mass divided by Avogadro number, right? You get mass of one sphere or one atom or one particle. So this part represents the mass of the unit cell, because mass of one atom into number of atoms, that is the effective number of particles, divided by volume of the unit cell. Now whenever you do problems, numericals, you should be careful about the units. Generally we follow SI units. In that case, molar mass, you know, the unit is gram per mole, because mole is defined in terms of mass in gram. So this will be gram per mole. Z doesn't have any unit, it is a number. A, edge length has to be in meter. Maybe it is in nanometer, picometer, you have to change it to meter. And Na, Avogadro number, it's treated as a constant, then it is mole inverse, number of particles per mole, so mole inverse is the unit. So keep that in mind. Let us go to some typical numericals here. The first one, you may take down the question. Nickel crystal. Atomic mass is given 58.7. So molar mass is 58.7 is the atomic mass of nickel, and it has an FCC lattice. It is said that it is FCC type of lattice, and this unit cell edge, that is A, is given as 352 picometer. 352 picometer is the edge length. Calculate the density. You have to find the density rho to be calculated. Okay, so density of nickel crystal is to be calculated. So you will use this equation. What are required? Z is required. Once you say it is FCC, it is equal to, what is Z for FCC? 4, isn't it? Z is equal to 4. Molar mass is given. This is to be written in gram per mole. This is atomic mass given, so we write in molar mass gram per mole. A is in picometer, you will change into meter. 352 into 10 raised to minus 12 meter. And Avogadro number is a constant, we know that. So we can substitute all the values and get the answer. So the question I repeat, nickel with atomic mass 58.7 has an FCC unit cell edge of 352 picometer. Calculate its density. So we will now substitute the values. Rho equal 4 into 58.7 gram per mole divided by A cube 352 into 10 raised to minus 12 all cube into meter cube into Avogadro number is 6.02 2 into 10 raised to 23 mole inverse. When you write the unit for Avogadro constant, it is mole inverse. You can see this get cancelled. Okay, and you get answer in gram per meter cube. Conveniently, you can change into kilogram per meter cube or gram per cc. In different units we represent density. Okay, that doesn't matter. You can change the units accordingly. So you can simplify this and get the answer. It comes out to be 8.938 into 10 raised to 3 kilogram per meter cube. Okay, this is the density of this nickel crystal. Now going to the next one. So one application of this equation, direct application of this equation, is to calculate density of a crystal provided you know the edge length. Where you get edge length from X-ray diffraction techniques, right? Sometimes you may be given interplanar distance d from which you can get A, and this is a constant. Molar mass is also a constant. Z you also get from the XRD studies. You can calculate density. And the second question, another important application of this equation is, if you could get density of the crystal from some other experiments, you can calculate Avogadro number from this studies, crystal studies, right? Write the next question. Density of copper crystal is 8.935. Copper crystal it is. Density is 8.935 into 10 raised to 3 kilogram per meter cube. The edge length of FCC unit cell of copper is found to be, so edge length A is given and it is said it is FCC crystal. Value is 3.6 degree angstrom from X-ray diffraction studies. Calculate the Avogadro number from using the data. Avogadro constant is to be calculated and atomic mass is also given 63.54. If it is molar mass, we can write it is gram per mole. So this is the atomic mass given. So these are the data given. So you can calculate Avogadro number rearranging this equation. Okay. So you have density given, A is given, this is to be expressed in SI unit. So 3.6 into 10 raised to minus 10 meter, that is degree angstrom. FCC, so it is Z equal 4. Molar mass is 63.54 gram per mole. So what you get Avogadro constant from this equation? Na equal, cross multiply, Zm divided by A cube into density equal, Z is 4 into molar mass is 63.54 gram per mole divided by A cube 3.6 into 10 raised to minus 10 whole cube meter cube, right, into density is 8.935 into 10 raised to 3 kilogram per meter cube. You can see how the units get cancelled. See, one point is very important here. This get cancelled, fine. But you see that kilogram and gram does not get cancelled. So you have to convert into either this into gram or this into kilogram. That's important. So this is advantage of keeping track of units while doing numericals. You should write all the units in all the steps. Okay. So what we can do is, this can be made into gram by multiplying into 10 raised to 3. Then it becomes gram. Now you can cut gram also and you can get the answer. By simplifying this, the value comes out to be 6.097 into 10 raised to 23, and you see the unit left out is mole inverse. That is the unit of Avogadro constant. See, it's very close to the theoretical value. Accepted value 6.02. Okay, slightly it differs. Avogadro constant, and look at the exponent. That's very important. 10 raised to 23 is obtained. Fine. We will do one more, another type of question. That is, so in the first problem we calculated density. In the second one we calculated Avogadro constant. Now the third one, write the question. The unit cell edge of cubic silver crystal, so it's silver crystal which is cubic, and unit cell edge is found to be 405 picometer. So A is given 405 picometer. Okay, it is silver crystal. The metal is found to have a density of 10.8 gram per cc. Density rho is equal to 10.8 gram per centimeter cube. Right? Calculate the number of atoms per unit cell and comment on the type of cubic lattice that it has. So you have to predict the number of atoms per unit cell. That means Z is to be calculated, and comment about the lattice type. That you can easily do. If Z is obtained as 1, it is primitive cubic. If it is 2, BCC. If it is 4, FCC. So basically the problem is to calculate Z. What are the things given? What else is given? Atomic mass of silver is also given, or the molar mass 107.9 gram per mole. Okay, so you have to get Z. Z is equal to cross multiplying density into A cube into Na divided by molar mass equal. Density is given 10.8 gram per centimeter cube. See the unit. This is picometer, so this will be meter. 405 into 10 raised to minus 12 meter. This is to be converted into, of course, SI unit. If you keep it gram, it's okay, it will get cancelled. But this is to be converted into meter. Or centimeter minus 3 is to be converted to meter minus 3. That you can easily do, by unit factor method. 1 centimeter is equal to 10 raised to 2 meter, right? 10 raised to minus 2, isn't it? Centi is 10 raised to minus 2. So to get the cube, 1 centi cube, taking the cube both sides, this becomes 10 raised to minus 6 meter cube. So this, 1 centimeter cube is this one. So if you take the ratio, like 1 centimeter cube divided by 10 raised to minus 6 meter cube, you can see that this get cancelled and you end up in gram per meter cube, and divide by 10 raised to minus 6 will be there. So density is 10.8 gram, 10 raised to 8 and what? Divided by 10 raised to minus 6, so that comes up into 10 raised to 6, it comes gram per meter cube into A cube. What is A? 405 into 10 raised to minus 12 all cube meter cube into Avogadro number 6.02 10 raised to 23 mole inverse divided by molar mass is 107.9 gram per mole. Look at how the units get cancelled. Gram get cancelled. Gram get cancelled. Meter cube and meter minus a meter cube get cancelled. Mole inverse get cancelled. And you get a mere number, that is Z supposed to be. You get a number. It's comes out to be 4.005, which is nearly equal to 4. So Z is 4. So effective number of particles per unit cell in silver crystal is 4. So what is your conclusion? This indicate that the crystal is which type? FCC. So silver crystallizes in FCC lattice. Okay. I am giving you two homeworks. Take down the homeworks. The first one, the density of aluminium. Okay. The density of aluminium. The density of aluminium, atomic mass or molar mass is given as 27 gram per mole, which crystallizes with an FCC lattice, is found to have a density is given 2.7 gram per centimeter cube. Calculate the unit cell edge. That means you have to find out A. So you can get A cube and get A after that. So there's a direct question. Then the second one, an element occurs in the BCC structure. BCC structure, element is not mentioned, with a cell edge of 275 picometer. A equal 275 picometer. The density of the element is 7 gram per cc. Density is 7 gram per cc. How many atoms of the element does 200 gram of the element contain? The question is, how many atoms of this element does 200 gram contain? See, if you are asked such a question, how many atoms in 200 gram of an element, you will think of the atomic mass or molar mass. So basically the question is to get what? Molar mass. Once you get molar mass, using mole concept, you can convert this mass into number of moles very easily by dividing by molar mass. So basically the question is to get M. Everything else is given. BCC means Z is 2. A is there. Na is known. Density is given. Check out the units and get molar mass, and after that you convert this mass into number of moles. Okay, so that's how you do numericals on this density calculation of crystals. Thank you.